Hello, I'm Hudson. Thanks for tuning in and welcome. Humans have always been curious of what's around them, and we have made tremendous achievements in doing so. From piercing deep into the heart of the atoms to looking outwards into the vastness of the cosmos. We have achieved a lot, but there are lots more to be learned than what we already know. In December of 2021, the Curiosity led the National Aeronautic and Space Administration, NASA, the European Space Agency, ESA, the Canadian Space Agency, CSA, and partners globally to launch the largest and most sophisticated telescope ever, the Hubble successor, the James Webb Telescope, into space. That infrared observatory itself was a wonder. NASA's top priority, a $10 billion time machine which took 30 years to build. Just like Hubble, named after Edwin Hubble, who discovered the expansion of the universe, James Webb's telescope was named after James Webb, who led NASA during the Cold War. And in December 2021, a Christmas gift was unveiled. The machine designed to look back in time was launched from a tropical rainforest in Guyana, France, because of its proximity to the equator. Its destination, Lagrange 2. Lagrange are points in space where forces of two bodies equal the centripetal force. They are like small parking spaces for small objects. Named after Joseph Louis Lagrange, a mathematician. L2 is approximately 1.5 million kilometers, roughly 5 times the distance to the moon.
And we have engine start and liftoff. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
And its mission, to probe the universe. One of the ways it does that is by looking back in time to a few billion years, or even 100 million years. 9.58 kilometers per second, the upper stage engine detached. It would go on to peer deep into planetary nebula. That's where the ability to use infrared comes in, and observing how stars are formed like never before. Studying exoplanets and possibly looking for signs of alien life. 6.5 months after launch, it started sending back images. If you could see through a grain of sand held at arm's length, that's the part of sky you're seeing. Every dot you're seeing is an entire galaxy at its infancy. Light from those galaxies have been traveling for about 3.5 billion years to reach us. If this particular galaxy was the same size as our Milky Way, shining a light at its edge through the center and out the other side, we know light covers 300 kilometers in 1 second. It would take light 100,000 years to travel the entire diameter of that particular galaxy. That bright spot you are seeing at the center is a collection of galaxies. It's massive, that it has curved space-time around it so much that light from galaxies behind it get carved into those shapes you are seeing as they follow the curvature of space-time. In fact, it could be the same galaxy, an Einstein cross. These are stars in our backyard, our own Milky Way, which got spiked in the process. This is NGC 3372, the Carina Nebula, a name derived from Latin, nebula meaning fog or cloud. It was discovered in 1752. It's over 8,000 light years from Earth. One special thing in this photo, we are seeing it in more details like never before. This is because the telescope is able to penetrate the gas cloud through the infrared spectrum, allowing us to observe newborn stars, jets, bubbles, activities we didn't have access to.
There it is. It's called Stephan's Quintet.
5 galaxies at close proximity. The 5th one is a bit far. These four are about 300 million light years from us. They are racing towards each other to form one big galaxy. The process is likened to a dance, as space-time tells them how to do it cosmically. They tell space-time the tune simultaneously. This is its near-infrared image. The telescope is able to analyze wavelength in its spectrum, understanding the composition of gas, velocity, temperature at a given area in this image. The next one is an indirect image of an exoplanet. When information started coming in about WASP-96b, it was greeted with joy, largely because of what Webb could do. This planet was discovered in 2014, and it's over 1100 light years from us, with a mass less than half of our solar system's biggest planet, Jupiter, and a diameter 1.2 times bigger. Its temperature greater than 1000 degrees Fahrenheit or 5000 degrees Celsius. Orbits its star 1/9 of the distance of Mercury to the Sun and revolves around its star in 3.5 Earth days. That's to say it has 104 new years in one Earth year. The signature of water along with cloud and haze in its atmosphere. That's done by analyzing its filtered star's rays in the infrared section as it passes through its atmosphere during transition. Sometimes we come up with theories to try to answer profound questions, then evidentially back them later. This is one of those scenarios where we try to come up with proof using a powerful tool. It's our hope that this time machine could tackle cases like the Fermi paradox and find whether we are alone. Either way, the answer is frightening. We have been trying to answer this question by gazing deep field and keenly tried to detect radiation emitted by a civilized society elsewhere. We've came up with clever ways in the process, like categorizing their level of intelligence, but came out empty-handed, or as some would say, cover-ups. To do this telescope will study environment of exoplanet in much more details, hoping to find a habitable environment where life could flourish. It will also try to figure out how the first stars and galaxies were formed those billion years ago. Due to Doppler's effect, it is tuned to a more stretched wavelength in order to have access to those bodies. The wavelength gets stretched due to the expansion of space-time, where receding light gets redshifted towards the infrared and an approaching light gets bluish towards the ultraviolet. This also enables us to calculate how fast a star is receding. We assume the universe was a point 13.8 billion years ago, and it started expanding, and the expansion has been accelerating. There are stars, galaxies, nebula, black holes which we may never see, because the rate at which space-time is expanding exceeds the speed of light. So their lights may never reach us, and the ones we are seeing is the observable universe. The telescope is able to take us back 13.5 billion years or so to the very instant it all began. Science is a tool handed to us by the Almighty to try to understand the nature of things and deal with very deep problems facing us today and in the future. Things like climate change, how to flourish in this challenging universe, and so on. Science may try to tackle problems, but like many tools, it has its breaking point, and we've tried to mend this by introducing other branches of science, like quantum mechanics. And one of the pioneers, Richard Feynman, once said, "If you think you understand quantum mechanics, you do not understand it. My students do not understand it. That's because I do not understand it." To some extent, this means that our knowledge of the universe depends on the limitations of our mind. This should not in any way discourage us from learning, but encourage us to do more. This clearly tells us that there are problems we cannot solve scientifically, as Ravi Zachariah, a profound Christian apologist, told us that the real problem is not that it is perverse out there, but the fact that it lies deep inside my heart and your heart. That's where the answer is. where God speaks to us. Our quest for knowledge has just begun, and we still have a long way to go. Thanks for watching.